coefficient. So what is it? It's represented by R sub phi, or just phi, and explains the association between two binary variables. So anything that has two outcomes, such as yes or no, or success or failure. It's similar to the Pearson product moment coefficient, or just your basic correlation coefficient. And if you calculate the regular correlation coefficient, you'll just get the same answer as you would if you calculate phi. And you can also calculate the phi based on the chi-squared statistic, which I'll explain a little more later. So how do you calculate it? Like I said, you can use the chi-squared statistic as your basis. So you can calculate phi by taking the square root of the chi-square statistic divided by n, or you can do it in a simpler way that'll get you the exact same answer by using the difference of the product of each of the diagonals divided by the square root of the product of the column totals and row totals. So the interpretation is similar, very similar to your regular correlation coefficient. So -1 to -0.7 is a strong negative strength and direction, and -0.7 to -0.3 is a weak negative. -0.3 to 0.3 is little or no correlation, and 0.3 to 0.7 is a weak positive correlation, and 0.7 to 0.1 or 0.7 to 1, sorry, is a strong positive correlation. So I'll give you an example using both of the formulas. For the first one, I'll use the chi-square statistic. Since yesterday was Halloween, I thought it would be fun to use an example that talked about trick-or-treating. So we'll look at the relationship between trick-or-treating and whether or not they got lots of candy. So first you have to calculate the chi-square statistic, which is just the sum of the observed values minus the expected values squared over the expected values. And the observed values are just what you collected for your data, and the expected values you can find by taking the column total times the row total divided by the grand total. So after doing those calculations, you end up getting that the chi-square statistic is 7.0267. And then to get the phi, you take the square root of that divided by 50, which was the total that I used in the example. And you get that phi is 0.3749, which indicates a weak positive correlation based on interpretation. And using the same exact sample, using the other formula, which just uses the column totals and row totals. So after you do the calculation using those, you get the same exact answer, 0.3749, which indicates a weak positive correlation, and it's much faster and more